Okay, I'm going to do 83 now. 83, I like 83 because it's different than 81 and some of the other problems where, say they give you revolutions per minute, they give you a radius, and you end up just multiplying by 2 pi, then multiplying by your radius, get your linear velocity. 83 really makes you think about those equations and how you can almost, not really work them backwards, but almost. So, looking at 83, they only give you two pieces of information. They tell you that the horse on the outside radius of this merry-go-round is traveling at 10 feet per second. But you also know that the merry-go-round is doing 6 revolutions in a minute. So let's write those down. We've got, well, our linear is 10 feet per second. Over here we have 6 revolutions per minute. Okay, so in general, here's that RPM we talked about in 81. The first step would be getting to angular velocity, which is just multiply by 2 pi. So we multiply by 2 pi radians per revolution. Revs cancel, and we get 12 pi radians per minute. So let's bring that down here. 12 pi radians per minute. That is our angular. Now the next step in most problems is, given the angular velocity, find the linear velocity. And to do that, you just multiply by your radius. So if you look at that, in this problem, 12 pi radians per minute times r would give us linear velocity. Well, we already know the linear velocity. They give that to us in 10 feet per second. So a couple things we need to work out here. We need to get from radians to feet and minutes to seconds. So let's do just the minutes to seconds. So 12 pi over minutes. We're going to multiply by 1 minute over 60 seconds. Radians cancel. Nope. Minutes cancel. There we go. And 12 over 60 is the same as 1. Then we have our pi term. Don't forget to carry that pi term. Radian per 5 seconds. Okay? So if I bring all this up top, pi radians every 5 seconds times r equals 10 feet per second. Now let's just temporarily, let's kind of forget about units right now, because we know that radius is going to be feet per radian. Let me just in blue put that in. You'll see what will happen. Again, radius is always like a linear distance, feet per radian, because radian really is the distance of one radius. So our radians would cancel and we get our feet per second. So now that we know our units are going to cancel, 1 over 5 times pi, we're looking at 0.2 pi, okay, times r is 10. So r is equal to 10 over 0.2 pi. Well, that's the same. So 10 divided by 0.2, or 1/5. 10 divided by 1/5 is the same as 10 times 5. But you have to leave your pi on the bottom. So 50 over pi feet per second. Nope, I'm sorry. Our seconds would have actually canceled. So you're just left with feet. Okay, you have per second on the left, per second on the right. Those actually reduce, and you're just left with feet. So r is about, well, it's 50 over pi, which is around 15.92 feet. Which is a pretty good sized merry-go-round, 16-foot radius. So again, just keep in mind, in any of these angular velocity, linear velocity, just know that from RPMs to angular, you multiply by 2 pi. And then once you have your angular, like radians per minute, just multiply by your radius, and you get your linear velocity, such as either feet per minute or miles per hour.